All right. All right. Those of you just now tuning in, we're live here in Minnesota, day 2 of the mining conference brought to you by Bitcoin Mining World. And we've got a lot going on here still today. We've got a couple of great discussions from our main stage. Our stage 2, of course, will be debuting a variety of fantastic content and information as well, the details of which I have no idea. But what's most important as well is we've got coming up to our stage in just a few moments, the one and only Alex Gibson. We'll be introducing him. Let me give you a quick reminder before we do that. By the way, we're going to be heading off to the facilities tour. That's right, our 25 megawatt just for crypto mining facility tour. That's going to be lunch served and the tour. And an important detail, we don't have a shuttle bus. We're counting on all of you to grab your items from here. We won't be returning. We're going to go to the mining facility, etc., and have a fantastic afternoon, and then a wrap up to the day with our Wicked Smart panel. That'll all be happening live at the mining facility. That's preview of this afternoon. But for right now, without further ado, from Greenidge, that's right, the next generation, of course, of air cooling. We've got the master himself, the engineer. He is the master troubleshooter, solutions maker, and the wizard of all things air cooling and engineering. Alex Gibson, come on up here. Please, everybody, give him a nice welcome and good morning.
There you go, buddy. Thanks, man. Appreciate it. Hello, everybody. And there we go. Cool. Okay, so hello, everyone. I hope you've been having a great weekend. My name's Alex. I am with Greenidge Generation, and I'm here to talk to you today about air-cooled mining solutions. So we've been doing air-cooled mining for the past 4 years. We've got a ton of experience in it, and with that experience, we've come to realize that there's some issues and flaws with the systems that are out there right now that we've been dealing with personally. Maybe you have as well. And we've been trying to innovate and come up with new solutions and fixes to these problems over the years. And I kind of just want to touch on some concepts that we've come to realize with our innovations. And some of those concepts include how pressure, velocity, and airflow can make all the difference. So air-cooled mining is where it all started. Ever since the first miner was created and you started mining yourself, the concepts of how to make the miner work are fairly simple. You have to have cool air coming in on the intake and a way to exhaust the hot air on the other side. And if you can do that, you can run your miners till their heart's content, make them happy, and make you lots of money. But there's outside environmental and climate factors that can put a damper on this and create something of a problem for your miners. So engineered solutions are the most likely way to go, which I'm sure a lot of you either own or have seen before. There's a few different variations out there on the market right now. Mining pods are a really popular one that a lot of people own. You got Giga, you got Easy Block, you got RK, hopefully you have ours. But you got mining pods, you got buildings that can either do double intakes and out through the roof, or just a streamlined building. You got racks that you can put into just any space that you've got power and area. And then at-home mining, which is probably where a lot of you started, just plugging into your garage and mining there. But no matter which one you use, everything requires air-cooled and finding that balance between your intake and exhaust. So with all that, with all the experience and all the air-cooled, you can get a lot of issues and flaws that might arise that you've either experienced, I know us as a mining corporation has, and these are some issues that I kind of want to highlight and talk to you throughout this presentation. So some of them, quick list right here, are just miners overheating at low temperatures. You got contaminants that can cover your filter and get them all dirty and messy, and weather that can get into the intakes of your pods. And then buying additional electrical equipment because they might not be up to code when you go to plug them in. And then your those dang intake doors that just, they just won't open because of all that negative pressure. You might be putting a lot of energy into trying to get your intake doors to open. So, there's a fair amount of issues that you might run into, and like I said, we have as well. And I'm here to really tell you that there is a solution and explanation to all the issues that we've experienced, and I want to share our experiences and what we've learned with all of you. Hopefully you take something away from it. So a little bit about me real quick. I am originally from Watkins Glen, New York. It is a gorgeous small little town in upstate. We're on Seneca Lake. We have a lot of wineries along the lake, and it's a beautiful place this time of year, so if you're ever in the area, you should definitely check it out. I got my BS in mechanics. And the best racing tracks in America. I do. Yeah, we have an awesome NASCAR racing track like 10 minutes from the town. It's what got us our name, so how could I forget? But I got my BS in mechanical engineering at Virginia Tech. Oh, nice. So, yeah, about 3 years ago, so go Hokies if there's any, probably not any Hokies in the audience, but there is. We travel well. And ever since I graduated 3 years ago, I started working at Greenidge. I started part-time while I was at college, and I went right into the engineering position out of college. I've been working on our site procurement team for the past 3 years, so I'll just go around the world, or not the world, the country to all of our sites and procure our equipment there with the rest of our engineering team. And just a little fun fact is I once walked a marathon with a couple of my friends, which I don't know if any of you have done or have thought about, but it is a lot harder than it sounds like. A lot of pain, but it's very rewarding, so you should try it. Just a little bit about our company. So we are Greenidge Generation. We are a natural gas-fired power plant in upstate New York. It's about 20 minutes from where I live on the lake. And if you watch the Dirty Coin documentary, we are featured in it. Currently going through all that fun mess up there, but we're confident we'll come out all right. We're a publicly traded company that has incorporated Bitcoin mining into our energy corporation. So as far as I know, we're one of the first, if not the first, to pioneer the idea of behind-the-meter mining, which basically means that the power that we generate on site, we use that generated power to mine Bitcoin. And our turbine has a capacity of 122 megawatts. We use about 60 of it for our mining currently, and the rest goes straight to the grid. And that equates to about 1.2 exahash of self-mining. So over the past 4 years, because we started mining in about 2020 or 2019, we have deployed over 20,000 machines. That includes self and hosting miners. And we deployed those into 27 different environments. So of these 27 environments, we've probably deployed every known environment that's out there on the market right now just to get experience with it all. And that includes a hydro mine. We have a house-made immersion tank, or 3 house-made immersion tanks that we did a while back. 2 8-megawatt buildings that we designed and built from the ground up. And then we have these cubes, which you can see a picture of them right here. It is exactly as the word describes, 4 gigantic walls of miners that we just wanted to pack as densely as we could. It was our first attempt at an air-cooled environment back in 2020. It was actually one of the first jobs that I was a part of. I was one of the guys that would go up all the stairs with the miners and plug them in. It was a fun job. But yeah, this was our first attempt, and we have 3 of these on site on the turbine deck. We have a lot of racks that we put into spare buildings and space on our turbine deck with power. And then, of course, our air-cooled units, our mining pods. We have 14 of them. It's a mix of Ant Box and Easy Block, and then our own Greenidge pods. So with all of the diversity in our mining environments, it comes with a lot of experience that we've learned along the way. And that experience, particularly with our air-cooled units, has led us to understand that there's some problems with some of the designs on air-cooled units. And there's the problems that we found is why we wanted to innovate and create our own. But these problems that I want to kind of highlight throughout the presentation are this list right here. We want to talk about our high intake velocity on the cool area of the pod, the excessive noise that some of the mining pods out there make, electrical compliance and safety, pod limited spatial density, and hot air recirculation. So let's get to it. So the first concept I want to talk about is understanding pressure and hot air recirc. They are, in fact, very much related. Pressure is kind of a concept you may not think about, but you definitely experience. Like with those intake doors that don't want to open, that's caused from a lot of negative pressure. But when you understand pressure, it's important to understand what your miner needs in terms of pressure, which is neutral pressure. You want your miner experiencing zero pressure at all, because then it's working a lot less harder than it could be if you have unbalanced pressure on either side. So how do you get this neutral pressure on your miner? Well, it involves speccing your exhaust fans so that the pressure that they are pulling is equal to the pressure drop across your intake. And the way that you can understand pressure drop in your intake is basically at your filter and louver level. You know, you have restrictions and restraints from your filters and louvers. That creates a pressure differential that when you add it up, your exhaust fans need to be able to either slightly overcome or equal that pressure to make it neutral on both sides of your miner. And if you can do that, your miner is going to be happy, its fans are going to run without restraint, and it'll run a lot longer and at higher temps throughout your mining cycle. Now, you might ask yourself, well, what happens if you have unbalanced pressure? Like, what happens if it's too high or too low on either side? Why is this a bad thing? And, well, like I said before, if you have high negative pressure on your intake, that can cause a lot of issues with weather and contaminants coming into your filter. It's probably what causes, or it's definitely what causes snow to come in if you ever have problems with snow in your intake. It's just because it's like a vacuum. It's just pulling so hard and so fast that anything on the outside gets sucked right in. And like I said, it's largely responsible for the high pressure on your intake doors. Your miner fan's quality of life will also be affected by positive or negative pressure. I mean, it's just a lot of strain on the fans on your miner. And like I said, if you really want your miner to behave the way it should, you just can't put any work on it. You have to keep it at neutral pressure on both sides. And then, of course, high air recirculation, which you probably know about, but in case you don't, here's a little graphic. So high air recirc is basically, it follows the simple concept of air-cooled. So if you have intake coming in at a cold temperature and exhaust at a high temperature, but you have really strong negative pressure on your intake that creates that vacuum-like that force, it can actually pull the hot air from around your intake or your exhaust back into your intake and overheat your miners. Now, this is particularly relevant with the streamlined air-cooled systems because of the direction you're exhausting your hot air. But if that negative pressure is so strong, it will do that, and you either have to, deal with it in hotter climates or provide some sort of reduction measures on both sides of your mining pod to try and block that air from coming around. Now, the opposite is also true with positive pressure in your exhaust, and that can be if your exhaust fans aren't really spec'd high enough to overcome or equal the miner exhaust fans. So if your miners are blowing out too fast and too hard that your exhaust fans can't keep up, that positive pressure builds up and it'll actually leak, and it'll leak back hot air into your intake from the inside, which also overheats your miners. So as I kind of talked about with high negative pressure on your intake, that can also lead to high intake velocity, which is also an issue that you might feel and realize. Now, to understand high intake velocity, it's important to understand what the optimum velocity of your miner intake should be, which we found by doing a lot of airflow studies with the miners that we have. We did a lot of variation studies to try and find that optimum velocity and optimum pressure differential. And what we found is about 340 to 415 CFM is what you really want your miner pulling in at the miner grill level on your intake. If you can get that, you can minimize your pressure differential across your miner because you might not pressure on both sides. Like with this speed right here, it's about 0.1, so it's very minimal, but you still get it. And then you also get a 25-degree delta T. So I think what we've realized is about 120, 125 degrees on your exhaust is when your miner tends to overheat. But at this CFM coming in, you can run it to 90, 95 with no problem. So what causes high intake velocity? Because your miner is going to be pulling in at 415, but that air is still coming in way too fast. So why is that? And that is because of two things that we've come to realize. One of them is not enough intake area. So from your intake areas from your miner intake grill all the way to your filter or louver. That space right there is key because you got restrictions on your filter and your louver that speeds up the air coming in regardless of what speed you're pulling at. And you need sufficient area in between there to slow that air down and get it to the speed that your miner wants to pull it into. And if you don't have that sufficient area, it's going to come in way too fast. It's going to cause a lot of negative pressure in your intake, and all the problems I mentioned before are going to happen. And then you also got the delta rack formation. So this is a kind of an overhead. You probably understand what this is. You've seen it in other mining pods out there or even buildings. It's a great formation for getting miner density because you can get more miners compared to a streamlined approach, but the problem is you get high intake velocity through each of those deltas, and that's because it acts as kind of a Venturi effect and like a vortex funnel that it's pulling air so fast at the front of the delta that it's actually starving those front rows, those front columns of miners. They're not able to suck in and overcome that high velocity to give them the air that they need. They actually starve. So you might get overheating in those front columns at lower temperatures than you might think. And it's just the way that the delta is. I mean, again, they're really good for density, but you get this high intake problem. And again, like because of your high intake, you can get that hot air recirc from the outside. So everything is kind of connected. And then excessive noise. This is a problem that you might, it's easy to realize, especially with air-cooled units, because compared to hydro and immersion, air-cooled units use fans, and fans are loud as hell. So when you're go back. So when you're using these units, it's important to understand exactly how much noise they're making and where you're putting them and who your neighbors are. Because if you don't worry about that and it comes back to bite you later because you're getting sued because you're too loud and your neighbors are complaining, it's going to be bad for you and it's going to be bad for the rest of us because it's going to put Bitcoin in a bad light. And there's quite a few companies that do this, but it's just something that you got to worry about if you're buying a streamlined pod is how much noise is it making. And we've clocked some of those pods to about 100 decibels, which is pretty loud. And if you're not careful or the place that you're putting them, you need to keep that noise down, you might end up putting some reduction measures in that cost a lot of money and time, some of which include like a noise study, sound dampers, curtains, or filters around your site. And this picture right here is our dampers that we put onto our 2 8-megawatt buildings in Dresden. They work phenomenally, but they cost a lot of money, and it's just something that you got to be aware of depending on where you're building. Limited pod density. So because of the direction that you're exhausting out a streamlined pod, you aren't able to space it as close as you might be if you were doing a different type of airflow. And that's because your exhaust, if you're pointing it at an adjacent pod and it's way too close, you're going to get that hot air recirc and it's going to overheat that pod at lower temperatures. So you're really limited. And what we've measured is about 75 to 100 feet in between exhaust on these streamlined pods, which equates to about 15 megs or 6 to 8 RK or easy block pods in an square acre area. So in our opinion, it's pretty low, and you could do a lot better with different airflow movement. And then just touching on electrical compliance and safety. So what we've come to realize is a lot of the units out there right now aren't exactly up to code as they should be. And you either find this out later if you get a code official coming to inspect your pod before energizing, and he points out issues that you might either have to add components for or just not run entirely. And again, this depends on where you're building. I mean, Texas is really lenient because it's just Texas. But a lot of other code officials, they might be reading the book to you like they did to us in North Dakota. So it just depends. But a lot of the problems that could arise are safety issues like arc flash. And if you don't know what arc flash is, to put it short, it is basically an accidental short circuit from phase to phase or from phase to ground. And the ground could be any of you. And when that happens, the short circuit creates an arc, which is like a lightning bolt. So, and that arc can reach about 20,000 degrees Celsius, and which is extremely hot, enough to burn you for sure, send you flying back, or even be life-threatening if the potential is really high. So it's something that you really need to be aware of. And there's a national code, NFPA 70, that you may have heard about. It's specifically meant to prevent and to require preventative measures to be taken on electrical equipment to either call out arc flashes or lower the potential. just like these arc flash labels right here. And like I said, it's an accidental short circuit, so it can happen at any time. You can't really plan for it. It could be something as simple as you holding a wrench when you're flipping a breaker on and off, and that arc will just come right to you. So you just want to keep it down, be aware of the hazards. So I kind of want to walk through just an example. This is one of the power panels on one of our air-cooled pods that we bought in New York. And in my opinion, it's probably just like a worst-case scenario for what you just want to look out for. A lot of pods out there have improved significantly in electrical safety. So yours might not look like this, but it's really important to understand the concepts before, like, even if you're not experiencing them, just to know what to look out for. So we'll walk through the design right here. So these 4 breakers right here are 1200 amp main disconnects in this pod, and they are feeding directly to the PDUs inside of the pod, which would be a code violation because there's no upstream breakers on those PDUs. You have to have breaker protection on your equipment if they're feeding directly to your mains, or it's gonna be a code infraction. So similarly, the 4 1200 amps are not allowed to be in the same container as each other because they're main disconnects. So this violates what's called a 6-handle rule, and I believe they changed the code in 2017 because originally this was allowed, but now it's not. If these are main disconnects, they have to be in separate enclosures from each other, so you would have to move them either to their own 1200 amp panel boards, or you could add an upstream main disconnect to these 4 breakers in the terms of, in this case, it'd be a 4000 amp. So either way, it's a lot of rewiring and a lot of money that you could potentially spend just to make this code compliant. So this particular pod has 6 VFDs. These follow the same error as the PDUs. They're feeding directly to the 1200 amps with no service disconnects on the upstream of those VFDs. You would need to add those as well just to protect those VFDs. And then probably the most egregious error is that you have exposed bus bar, which is a huge no-no. That is very high arc flash potential. You know, if you see any exposed bus bar at all, like, it's not going to be good. You need to keep that arc flash potential down. Actually, it wouldn't be safe to even operate any of the switches in here without using a full arc flash suit. So it's just something to be aware of. And again, RK has made extremely great advancements in their protection in the power panel, and a lot of other pods have too. They also may require an upstream disconnect on their 800 amps, but you know, it's just important to be aware of all these problems. So we decided that something needed to change. You know, we were tired of the same problems and flaws in all these systems and thought that we could do it better. So that's what we tried to do, and we created this model right here, or what we call our PodX, which is our solution to air-cooled mining. We took all of our lessons learned and put it into one solution, and this is it. And the general specs are, it's a 3 megawatt mining pod that's same size as a shipping container with 4 feet on both sides for intake. We use vertical air movement instead of horizontal. And our capacity is a little less than 800 miners for S19s and XPs and 73221s. And we have 2 alternate sizes as well if you wanted to go a little smaller or less power capacity. So we exhaust to the sky, which is obviously a different solution than going streamlined. You might see this a lot in buildings, but we're a lot more confined to buildings. And this really helps to limit and actually get rid of that hot air recirculation I talked about. Because hot air wants to rise, so we're just letting it do that. And by keeping our negative pressure and velocity low in our intake, there's really little to no chance of hot air recirc, so we can run our pods and miners at much higher temperatures. Also, because we're pointing our fans to the sky, the noise is significantly reduced, which I'll go into later. And we can maximize our pod density. So this photo right up here is of our South Carolina site we built. It's about an acre, and we can fit 30 megs into 1 acre, which is about 10 pods. So compared to other pods out there, it's about double the size. Because we can space our intakes only 20 feet from each other, we're not pointing exhaust air at an adjacent pod. So like I mentioned, we have low decibel output. We clocked ours at about 82, 83 decibels when we're 10 feet from our intake, which is about a 20% difference from other mining pods out there. So if you're really noise concerned at the site that you're building at, this would be a really good solution for you. It's definitely helped us in New York because we have to keep our overall noise down there. And then we lowered our intake velocity. So we did that by fixing the problem I told you about before. We increased our intake space by double the size. And that really helps to slow that intake air coming in. You know, the way that our pod works is we have 2 intakes on both sides. You can enter both of them. This is a picture of the inside of one, actually. So we're sucking air in and then blowing it out through a hot aisle in the middle. And that intake space is about 4 feet. It's enough to slow the air down coming to the miner so it gets exactly what it needs. And we can run our miners much better and much more efficiently. Because we have slow intake velocity, you know, we're not getting any contaminants or weather inside of our pods. We have no issue with rain, no issue with snow. We operate in North Dakota, and it snows a lot there, and we just don't have any problems with snow. And then, you know, the walking space inside of our intakes is really good for miner management. I mean, it's a lot different than the tight space in the deltas. Very easy for techs to go in. And then our straight line rack formation is different from deltas. It helps with that lower intake speed. There's no angles a miner has to overcome to get air, and the air distribution is much better. And then neutral pressure. So we got neutral pressure across our miners. This is how we did it and the process that we did it. And it all starts with speccing your fans. So we have five upblast fans on the roof, and we spec those to overcome the pressure differential on our intake, which if you add it up, we have about 0.3 inches of static on our filter when they're completely covered in debris, 0.2 on the louver, which equates to about 0.5 in total. Now, typically you'd spec your fan to 0.5, but you also have that 0.1 inch of static over your miner because of the 2 fans on your miner. There's pressure differential across your miner. So we spec'd it to 0.6. It works perfectly. And then you might kind of ask, like, if your filter loses all that debris, that pressure will drop. So then your fan's going to be running more than the pressure in your intake, which is totally fine if you're not overdoing it. If your fans are helping out your miner exhaust fans, it's actually giving them less work to do, and which is what you want. You don't want your miner doing any work at all, and this helps to do that. But if your fans are way over, it can actually, your miner will be a resistor, and it can affect the life of your miner. We're also electrically compliant. You know, we have all of our short circuit ratings are up to spec. Our engineers have gone into great detail to make sure that we are electrically compliant, so kudos to them. I know I'm getting a little rushed off, so I can cover this later, but you know, we've added disconnects over our VFD panels. We have breaker protection on our PDUs. We don't have any exposed bus bar, and our arc flash potential is really low. And there are the VFD disconnects right there. And also just a really quick slide on our filtration. We use 18 of these dual plush filters on all sides of our pod. They are completely reusable. You can take them off, wash them, put them right back. They catch everything. And it's a big difference from the one-time use filters that might cause you a lot of pain and trouble and money to just replace and store all the time. So these have been very helpful for us. And then we're deployed across the country. Here's just a little snippet of the 4 sites that we've deployed. We've been deploying these for the past 2 years, and that's where we've gotten all the data. We've been self-mining for 2 years, and we started marketing about 3 months ago, so we feel confident that they will perform anywhere. We almost did a site in Texas, but it didn't go through, but we're confident that dust wouldn't be an issue either. And then just to wrap it up real quick, you know, neutral pressure makes your miners happy. You want to have your miners doing as less work as possible to be most efficient. Don't be loud to your neighbors or they will get really pissed. And, you know, be mindful of electrical safety. You want to keep yourself safe while also being aware if you might have to spend more money to not violate any codes when you energize your pods. And then lower your intake velocity so that you know you're not pulling any contaminants in that might ruin your intake. And then yeah, if you're looking for an air-cooled solution or something different than what's out there, you can try us. You can come talk to me. I'll be out at the booth over there with the model. You can see all the inner components of our model. You know, we are self-miners and Bitcoin miners first and foremost. You know, we're just like you. And we wanted to make a solution that was better for us, and now we're here marketing it because we believe it might be better for you. So visit us at our website, come talk to me, get a koozie, and yeah, hopefully we can help you out. Thank you.